And gentlemen, keeping an eye on the current weather conditions over the Midwest and the Great Plains out there. This is the Severe Weather Watcher. If you're on Facebook, Weather Watcher 2, Severe Weather 2, I mean, from YouTube. And so looking at the current conditions, still got that convection outlook that's going on. Taking a look at the Weather Service, see if there's any updates on anything, and it doesn't really look like it's much different. I checked out a couple of reports from some other meteorologists in the area out there, and they were looking at some other interesting data and things like that. And we're all pretty much saying the same things. It's going to be one of those weather-aware nights all throughout the night. Several rounds of storms going through, and a lot of things going on. So, taking a look at the models. Actually, I'm gonna bring you over to Tropical Tidbits. I got there's a new radar. It's a newer version of the radar, and it's this 5v3 high res. It's a high res model, and it's really accurate now. It's kind of a new development in radar technology. So it's really good. It shows a lot of good details and everything. So we're going to take a look at that. But anyways, what's going on right now? This is 5 p.m. That we're looking at over Oklahoma. You start to see those cells popping up and everything. And get these little isolated cells that are just kind of popping up. Now, the problem is, and I didn't mention it earlier, is that warm wind that's coming up. And I'll show you actually on my radar here. And I'll show you what I'm talking about. I'll turn the winds on so you can kind of see, and it'll give you a better perspective of what it is as soon as the winds catch up here. And the winds are probably going to, yeah, it's going to just blanket the screen here because there's a lot of wind going up here. So this big sector right here of these southerly winds that are blowing into this area, up into this low pressure system, they're getting caught in here. This is theta E advection. So what we're looking at right now with that theta E advection that's possible, see what theta does is you got a lot of this rich, warm, moist air masses that are coming into these areas, and it's changing the air, the air composure of the atmosphere at that point. So basically, it blows what's coming from the west and the northwest out of there, and then this comes in at a lower, usually a lower altitude, and takes its place. Essentially, it removes it. So a lot of shear going into this area, and then when these theta E advection systems kind of blow into these areas, that hot, rich, moist air mass, and you can see it coming right in there from the south, just blowing real hard in there. It kind of comes to a narrow passage where you're getting pretty much from the line of the storms on the back of it right here blowing through, and then it's just this big alley like this of massive instability. Pretty much right now, what we're looking at is just on pretty much the other side of this warm front to about Oklahoma City, is kind of going right through, basically right just probably prior to or right through Oklahoma City is that alleyway of unstable air mass coming from that theta E advection. That is the likely position in these areas here where where you're going to see the most tornadoes popping up. You can already see we got some severe thunderstorm warnings popping up here, kind of blowing off and rushing off to the northeast. These are going to come in, and it's going to take their places through that unstable air mass of theta E advection. Going to get in there, and it's going to start dropping tornadoes probably about anywhere from 6 to 7 o'clock. This whole show is going to start. So that's really what we're looking at. And the likely case, we've said it before, we're looking at a lot of potential for multiple, just multi-cell supercell systems rushing through Oklahoma. So you're going to have a lot of supercells just spawning, popping up, popping up. Where they're going to pop up, that's the only thing the models cannot foresee. But it knows that inside that unstable air mass right there in that theta E advection, that's where they're going to pop up, is right in there. Just I don't know where along that passageway they are going to pop up. All right, so that's the issue there. Then later on, as it moves through, the only question I was watching meteorologist Aaron Tuttle. He's actually really good, and I've learned a lot of things from him as well. And he knows what he's talking about. He rose a great question in one of his videos, and I didn't even think about it. But that alleyway of unstable air and that theta E advection, The big question that he had was, is this going to travel east with the storms, or is it going to stay where it's at and the storms are going to move out of the way of it and then eventually weaken? By all the Cape levels and things like that, the tornado parameter that we see throughout these hours, it looks like these storms are probably going to move out of that air mass and then eventually weaken and destabilize. That's not to say that doesn't mean that you're not going to still have damaging winds, torrential rainfall, and possibly some hail possibilities there, as well as tornadoes. You could have a frontal, because this thing, when it comes up to this point about Oklahoma City, then it starts to narrow into a narrow line, a squall line of storms. And when tornadoes form on a squall line, typically, more than not, they kind of form along the front of that squall line. And if they do, they're going to be relatively weaker and they're not going to last very long. All right, so that's the good thing that we're hoping, that it moves out of that air mass, starts to destabilize before it continues east and northeast. It'll rush off to the northeast. Same with these cells here that are popping up are going to do. But one model says that it might travel a little bit east with the storms for a little while and then eventually taper off. And so they were hoping that Oklahoma City is not going to be directly in the center of these storms rushing through here, because obviously a lot of bad implications, a lot of damage, things like that. So hopefully it'll move out of that region before it reaches Oklahoma City. That's what we're kind of banking on here. All right, so that was just wanted to show you guys that. So now we're going to go to tropical tidbits, and I'll show you a little bit of what I'm talking about. You're starting to see these cells popping up right here. This right here is that channel of unstable air mass that I was talking about, that theta E advection. This is where that's at. And I can show you actually in pivotal weather a little bit more accurately where you're going to see that alleyway there. All right, now you start to see these cells that are popping up and tearing off to the northeast like that. Anytime you see that, it definitely means that there could be strong supercells right at the end of this, as well as tornadoes. Tornadoes can drop from these at any moment. These are probably most likely going to be tornado producers tonight. That's really the possibility. Even when we go into the later hours, as we said, this is 5 o'clock, 6, 7, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3. So 3 in the morning, you know what I mean? You're getting another round of it. You're getting several rounds over and over again. You know what I mean? And it just blows on through the morning like that. And then eventually, once it gets further east into Oklahoma, from what we've seen, that's that squall line that it's supposed to be kind of making. And on these squall lines, these thin kind of squall lines, sometimes there could be tornadoes embedded in them. But if they're towards the front of the squall line, typically they're not going to last very long. They're going to be pretty weak. So that's what we're looking at. Anywhere, you know what I mean, in these areas where you're seeing these cells popping up, that's where they're going to be. And even these storms, they look blobby on here and everything, but they still could possess some supercells and some tornado makers. Definitely hail makers in with this as well. I wouldn't doubt if we're going to see a lot of hail cores with these storms attributed to that tonight. All right. As far as the other stuff here, let's go to the high-res model on here. And, well, actually, no, I can use GFS. All right, so theta E wind barbs. This is one thing that I wanted to look at. So this is showing that there's that unstable air mass that's kind of pocketed over Texas at this point right now, and as we progress further in the models, then you can see that air mass moving up into Oklahoma. And there it is right there, just bolting all the way across to Oklahoma there, where you're getting 546K, just moving into that area, and that's that unstable air mass. That's and look at how it blows up right there. It's just, you know what I mean? It's one frame. It's kind of a little still, it's there. It's definitely there at high levels and a little bit more narrow, and then it just kind of blows up. But as the night progresses on, then it starts to de-intensify. You can see it weakening there. And then the front, this is that cold front that's kind of pushing through. as these kind of formed along the dry line earlier. This front is pushing through here, and then eventually just pushes it out of the way. All right, so you can see how that kind of works there with that unstable air mass, and anywhere along that air mass, with this big tail that's shooting up through Oklahoma, inside of that anywhere there could be embedded tornadoes. You're gonna have tornado makers more likely in that area than any other area. Afterwards or before. We might get a little bit of an early show to it. It might get started pretty early. We don't exactly know. Let me go to severe weather. That's what I was looking for. Surface-based CAPE. Let's look at surface-based CAPE here. You can see those CAPE levels as we continue on through the evening, and then into that overnight period. You can see those CAPE levels that are just kind of brushing through, and then eventually in the early morning hours, then it starts to taper off and starts to weaken. Still there a little bit, but not at a really intense amount. But you can see these dark blues here already reading over 1,000 in surface-based CAPE. Some of these these lighter areas of blue, you know what I mean? You're almost looking at 2,000 in CAPE there in some areas. Orange, over 2,000s, anywhere from 2 to 3. And you know what I mean? Some of these areas here are getting very high CAPE levels. All right, so let's look at storm relativity helicity. So you can see that helicity, that's going to give the storm the power that it needs to really pack a punch. All right, but you can see these big glowing purples. Look at that. All these big glowing purple and brownish colors here. These are very high indices of that helicity. So right there in that area right here, where we're looking at in Oklahoma, I mean that's the ticket right there. That's your golden potential for tornado development right there. And it's not something that's going to go away very quickly. It's going to kind of hang around for a little while. So it's going to be kind of slow going through, and then later on, like I said, in the early morning hours, as this kind of blows through 3-4 in the morning, then it starts to move out of that area and it starts to weaken and de-intensify. All right, so that's what we're kind of looking at with that. Let's look at supercell composite. Let's take a look at that. Looks a little bit like the CAPE. But now you can see those highlighted areas. So this is that supercell composite that is in that unstable air mass for the theta E convection right here. And you can see that big yellow spike right there where you're getting very, very high indices of supercell composite, 1.7 in some areas, 1.6, you know what I mean, 16, 17. Look at that. Very, very high indices, 14, 17. So you're getting all these big fat areas of just massive supercell development, and then eventually tapers off as it goes further east. I'm looking for the I can't always remember where everything is at on this. I'm looking for the significant tornado parameter, but I don't see it in here. Let's look at our bulk shear here. All right, so this is our wind shear. That's the biggest problem tonight is the wind shear is going to definitely be there. Tonight we're already getting damaging winds in some of these areas. This wind is blowing through with the cold front and that land cyclone, that low pressure system pushing in there. That theta E air mass, as soon as this blows through with that wind shear and it's kind of pushing these storms along, it's just kind of giving them that fuel to drive severe weather down to the ground here. To be with those high wind levels. You can see these big red levels of just nothing but really high wind shear, and that wind shear is definitely going to be there, and that's the kind of stuff. The way it's moving here like this, it's really supporting updrafts, and so that's gonna be what's gonna really get your supercells rotating, get some storms rotating. So that's the biggest issue that I'm having with that. We're going to go back to this. Let's look at some of this data here so I can show you. There's that dry line that you're coming, that I was talking about. So as soon as these storms roll across with this cold front, come across the dry line, they're going to be forming pretty much right up in front along this dry line. and by that time it's going to be right there in that uncomfortable air mass over here over Oklahoma. So all right, temperatures looking at 83, 86. So I did that video earlier today. We had lower temperatures here. You can see how these temperatures are really jumping up here on the panhandle of Texas. Already 72 up in Kansas. So that means that, this 80 pocket of heat, this 86, 83 is starting to move, it's going to be moving into that region of Oklahoma, and that's just going to further your chances for severe weather and instability even that much further. We're getting that wet sector in there. Doesn't look very bad over here on the panhandle of Texas here, but you're getting that wet air mass where that theta E advection system is blowing up into across Texas and into Oklahoma. That's where you're getting all that instability right there, that just alleyway of just nothing but bad, unstable air mass. And that is a lot of that reason. It's just very, very wet, moist air. And that's going to further the instability and be able to really ramp up those storms and get them spinning. All right, so 3,000 in Cape, it looks like, right on the border of Oklahoma and Texas. Looks like 2,000 up there off of Kansas up here. So you're getting those really high levels of Cape. 3,000 surface-based Cape is what they're reading from the National Weather Service. That's pretty thick Cape levels. A lot of instability there. You can see these wind shear amounts: 110, 100, 90, 80. This is knots. 110 knots of wind shear that's gonna be blowing through here. We already got 60 over here in Oklahoma. 60 knots of wind shear is definitely going to be enough wind to push any storm into a rotation and maybe, get some tornadoes spinning. 25 to 75 is surface vortice right there on the corner of the panhandle of Texas and eastern or western Oklahoma. So I mean, it's not a good sign, A lot of supercell, strong supercell composite that's in here that they're reading as well. And look at that tornado parameter. Tornado parameter is 5 in the center of this right here. We're looking at, 4 right here, 2, 2, 2. I mean, these are high indices of significant tornado parameter that is definitely going to get these storms into some possibly some damaging tornadoes, very intense tornadoes. It's going to be one of those long-lived nights, where you're going to have to be on your toes tonight. Definitely pay attention to what's going on. This is the EHI, the helicity that I showed you in this model here as well. And I showed you that helicity is really, really ramping up into these storms, giving them that punch that they need. Lifting condensation levels are already at 500, so it's a lot lower. And we saw it this morning when I did the broadcast, was around 750. So that lifting condensation is really going to be sinking. And that's kind of your indication there. And a lot of that is because of that moist wet air mass that's there too. You're getting a lot of that sinking level in that helicity. All right, so we're thinking about everybody in this area tonight, and I just wanted to do another update on the current conditions and show you exactly what we're looking at for tonight. And I hope that everybody stays safe. It's going to be a long night for everyone, and it's already kind of starting out there. So I hope everybody stays safe and makes it to the morning. And we'll be thinking about y'all. Come back and check out any other updates I might have going on, and be weather aware. Listen to your warnings. Have that plan in place. Keep your family safe, and I wish everybody luck.